Welcome to Calculating Acceleration using a Hot Wheels track and a marble run. We've been talking about acceleration, force, motion, Newton, and we need to be able to see that we can calculate acceleration using things around our house. So what is acceleration? Acceleration is a change in velocity over time. So that is represented as delta V over delta T. And we've talked about how that delta just means change. So the delta just means change. Change in velocity over change in time. We do not know all of these values for our experiment today, so we're going to have to do some calculations to figure them out. For example, we will need to calculate speed using the distance of both of our tracks divided by the average time of our trials. Once we figure out speed, we can figure out change in velocity. Now, remember, velocity is, we have to add that direction in there, which we know. Once we figure out change in velocity, we can plug that in to figure out acceleration. And we can figure out acceleration because we've now found a change in velocity. And we know the amount of time that it took because we figured that out in the beginning. Here's the steps we're going to do. Step number 1, measure and record the distance of the Hot Wheels track. Step number 2, perform 3 trials on the Hot Wheels track, recording each time, which is the best part. That's the most fun. Find the average of those times to use in our speed equals distance over time formula. And remember, to find the average, we're just going to add those 3 times up, those 3 trials, and divide by 3. Number 4, we will measure and record the distance of the marble run. We will then perform 3 trials on the marble run, recording each time, which, like I said before, is the most fun part. We will find the average of those 3 times to use in our speed equals distance over time formula. And then we will calculate speed. Now, we will use our speed calculation to calculate change in velocity. Once we have found change in velocity, we can calculate acceleration by using our acceleration equals change in velocity over change in time. Grab some paper to take some notes to follow along. If you want to do the calculations yourself, grab a stopwatch so that you can record the time of each trial right along with me. And if the time that you get is a little bit different from the time that I found, that's okay. Use your calculations and then you can send them to me and we can figure it out. So the first thing we did was measure the distance of the Hot Wheels track. And what I did was I took a piece of string and I laid it on the Hot Wheels track, cut it to length, and then I measured the piece of string. And I found distance to be 76 inches. So we will do 3 trials to make our data more accurate. Then we will find the average of those 3 trials, and that will give us time. Okay? Trial number 1 was found to be 1.9 seconds. Trial number 2 was found to be 2 seconds. Trial number 3 was found to be 2.2 seconds. Let's find the average time of those 3 trials. To find the average time, we add up these 3. So we have 1.9 plus 2 plus 2.2. That gives us a total time of 6.1 seconds. Average time To get the average, we will take that 6.1 and divide it by 3. That gives us an average time of 2.03 seconds. Let's calculate for speed using our speed formula of speed equals distance over time. Our speed is our unknown. That is what we are calculating for. Our distance was found to be 76 inches and our time was found to be 2.03 seconds. So we do speed equals 76 inches over 2.03 seconds. That gives us a speed of 37.44 inches per second. Let's use that calculation to calculate for velocity. Remember, our change in velocity formula is our initial velocity minus our final velocity minus our initial velocity. And our initial velocity was 0. We started from rest. So that turns out to be fairly simple. So it's just 37.44 inches per second minus 0, because remember we started at rest, so that would be 0. And our velocity was found to be 37.44 inches per second. Let's use that to calculate for acceleration. So we're now on our third calculation. So acceleration formula is acceleration equals delta v, which is change in velocity, over delta t, which is change in time. Now we are solving for acceleration. That is our unknown. We know change in velocity, we just found that. It was 37.44 inches per second. We know our change in time, we found the average of our time, so that was just 2.03 seconds. We plug those values into our formula and we get acceleration equals 37.44 inches per second divided by 2.03 seconds. That gives us acceleration equals 18.44 inches per second, or 18.44 inches per second squared. Alright, we have finished our acceleration for our Hot Wheels track. Let's move on to our marble run. Measuring the marble run was a little bit more tricky than the Hot Wheels track. To measure it, I taped the string to a marble, then fed the marble through the track. Once I had it all the way through, I cut the string to length, then measured the string. Distance was found to be 10 feet. You can see here I have the marble taped to the string, and then if you look here, I fed the string through the marble run track, the whole track. We also did 3 trials to make our data more accurate. We will then find the average speed. So the speed for trial 1 was 10.26 seconds. Trial 2 was found to be 11 seconds. And trial 3 was found to be 11.13 seconds. We will use those 3 trials to find the average time it took for our marble to complete one whole run through the marble run. So we're going to do the same thing that we did for our Hot Wheels track. 10.26 plus 11 plus 11.3, and then we will divide that by 3. So those 3 times added up gives us 32.39 seconds. So we have 32.39 divided by 3 gives us 10.80 seconds. that is our average time it took for our marble to do one run through the system. So let's use that to calculate for speed. Since we now know distance to be 10 feet, we measured it, and we know our time to be 10.80 seconds. We can plug that in to figure out for our unknown, which is our speed. So we have 10 feet divided by 10.80 seconds. That gives us a speed of 0.93 feet per second. Let's use that to calculate velocity. And our velocity formula, remember, is delta V, which is change in velocity, divided by our final velocity minus our initial velocity. And our initial velocity is 0 feet per second because we started from rest. And our final velocity is 0.93 feet per second. Let's plug those values in and solve for our unknown. So we have 0.93 feet per second minus 0 feet per second. That gives us a change in velocity of 0.93 feet per second. Yet, let's use that value to calculate for acceleration. We have our acceleration formula. Acceleration equals delta V, change in velocity, divided by delta T, change in time. We will plug those values in and solve for our unknown. We found our velocity to be 0.93 seconds and our time was 10.80. That gives us 0.93 feet per second divided by 10.80 seconds. That gives us 0.09 feet per second, or 0.09 feet per second squared. That was a lot of calculations and super awesome. I feel so smart now. I hope you do as well. I am going to challenge you. What can you find around your house to recreate this activity? Give it a try and send me your results. I'd love to see them. Be creative. Be inventive. Give it a try.